Hello, welcome back. This is another H230 AS Maths, and we're looking at question 10 of the OCR 2019 AS Maths and Mechanics paper. So this is our question. We're looking at the mechanics section today because we've done 1 to 8. So question 9, just a quite straightforward 2-point question. Three forces acting on a particle. The particle is in equilibrium with the action of the forces. Calculate F. That's pretty straightforward. So what we want is question 9. We've got 7 minus 6. We've got plus 2, 5. Plus the third force, which we'll just call xy, and it's in equilibrium, so it means it equals 0, 0. Put these two together, you've got 9 and minus 1, plus xy equals 0, 0, and therefore x must equal minus 9 to make that into 0 when you add them together, and y must equal 1, and so our force F, pretty straightforward, equals minus 9, 1. There you go, nice easy 2 points. Hello, maths, piece of cake. Honestly, might have been dry. Right, next question. Oh yes, anyway, not the full head of it, that was quite hard. We've got this graph on the second question, so we've got this, what is it, the velocity time graph, so then it flattens out here somewhere. We've got 18 up here, we've got 9 on the flattened out bit, so 9. Then we've got there's a 5 there, there's a 10 here. Okay. We've got, diagram shows a velocity time graph modelled, Velocity time graph modelling the velocity of a car as it approaches and drives through a residential area. The velocity of the car v at time t seconds for the interval 0 to 5 for this second, so this curve, is modelled by an equation. So we've got v equals pt squared plus qt plus r, where p, q and r are constants. Given that the acceleration of the car is 0, so a equals 0, at t equals 5, so when t equals 5, and the speed of the car then remains constant, so I've got to find out all the different things, haven't I? Okay, so let's have a look where we're going to go with this one. Well, the first thing I'm spotting is this point here. When t is equal to 0, we've got the velocity equals 18, so when t equals 0, v equals 18. So we run that through there, and we get 18 equals p times 0 squared plus q times 0 plus r, and then clearly r must be 18 because these are going to disappear. So r must equal 18. And what I like to do when I'm doing the questions like this is, as soon as I find a value, I like to rewrite the formula. So I'm just narrowing the formula down. So v equals pt squared plus qt plus r. Okay. The next thing we know, looking at the graph, we know when the time is 5, then the velocity is 9. So we know that from the graph as well. So let's go with that one. So when t equals 5, v equals 9. So 9 equals 25 p's plus 5, oops, I should put 18 there, I like to rewrite it with the actual numbers, silly man, plus 5q, and then you've got plus 18 at the end there. Okay, so this is just going to give me 25p plus 5q equals minus 9, just bring that 18 across and then just swap them around. So obviously I'm going to run into a simultaneous equation at some point here. Let's go to the next bit then. So we've got the acceleration is 0 when t equals 5. Well, acceleration is the differential of the velocity, so dv by dt. So I'm just going to write acceleration instead of dv by dt. So the acceleration is equal to 2pt plus q. So that's the formula for this one. So bring down the 2, take the power away, just get rid of the t, left with the q, and that one obviously disappears in the differential. So now we can use this result when a equals 0 and t equals 5. So 0 equals 2 times 5 is 10, so 10p plus q. So that's a. So what I'm going to do now, what should I do? I think I'll just find the right q. So q is equal to minus 10p's. And then I can take the 10p and throw it up here and figure out what p is from there. So I've got 25p plus 5 into minus 10p, so that's the q, equals minus 9. That's obviously going to give us minus 50, and then you've got 25 there, so it's going to be minus 25. So minus 25p equals minus 9. Obviously the two minuses are going to go away, so p is equal to 9 over 25. And if you wanted to get your calculators, you can, if you're a bit scared of fractions. P is equal to 0.36. So that's that one. And then we can use p equals 0.36 into our formula. Q is just minus 10 lots of that one. So Q is obviously 10 lots of that is 3.6, minus 10 lots of it from up here is minus 3.6. So there's Q. Okay. And then we can finish with our, the equation for the velocity up here. So V equals, I'll just finish there because I might have that formula to finish with. So V equals, P was 0.36 t squared minus 3.6 t, and then we had the plus 18 at the end, didn't we? Alright, let's just check everything. So we've got 18 there, Q is minus 3.6 and 0.36. There's our velocity. Okay. So that's that part. So that's part A. Part B, calculate the distance travelled by the car from t equals 2 to t equals 10. Okay, so all we want to do is our 2 over here somewhere. So there's 2. And then we've got this part here as well. Now velocity is just the area under the curve. So I'm going to do an integration of the formula from here to here between 2 and 5. And then this bit is 5 wide, 9 tall, so that's just 45 in there, isn't it? Okay, so we've got 45 to add on at the end once we've done our integration. Okay, so now I'm just going to integrate the formula. So I want the integral of 0.36t squared minus 3.6t plus 18 with respect to t between 2 and 5. And this thing is equal to, so add 1 to the power divided by the new power, so 0.12t cubed minus add 1 to the power 2 divided by the new power 1.8t squared plus 18t between 5 and 2. Okay, and then you can go and run at your calculator and start hitting the numbers. So let's have a look at the numbers say. So we've got on our calculator, I don't know if we can see the calculator or not, I've got 0.12 times 5 cubed, 5 and then cubed. Where's our cube button? There should be a cube button on the calculator somewhere. There's no cube button, so I can't see it, so I'll just put a 3 there. Take away 1.8 times 5 squared, and then plus 18 times 5, so there's that one. So just work that through, that looks like 60, so it's equal to 60. Take away, and then just go back and change the 5 to a 2, 3 to 2. Some people who are clever than me can do integrals using just the calculator buttons, so there's some other way of doing it, but it's like doing maths properly. And I've got 29.76, so that bit equals 60, take away that answer, and I've got 30.24. Okay, now don't forget we had the 45 from the other side where we did the area under the curve. So we've got now the distance. So the distance travelled is 30.24 plus the 45 from earlier equals 75.24 meters. Okay, and we'll stop there because that's getting up to 8 minutes. Oh, just past 8 minute mark. Okay, bye.